Hello, my name is Robert Hudson, and this is a presentation on the Fukushima power plant disaster. On March 11, 2011, a 9.0 earthquake and then a 13 to 14 meter tall tsunami wave resulted in a loss of power at the Fukushima Daiichi plant. The absence of electricity caused the failures of cooling systems in three reactors, leading to overheating of their cores. This sequence of events culminated in a partial meltdown of the fuel rods, a fire in the storage reactor, explosions in the outer compartment buildings due to the buildup of hydrogen gas and the release of radiation into both the atmosphere and the ocean. This is a video that talks about the whole tragedy. The main cause of this is the failure of the tsunami walls. Although a previous report warned that a tsunami could rise up to 33 feet, the walls constructed at Fukushima reached only 19 feet high. Reports indicated that the wave hitting the, the island reached a height of 40 feet. If the engineers had constructed the walls just 10 feet higher than the anticipated wave height, this situation might have been prevented. Also, the backup generators failed. This is mainly due that the units 1 through 4, the emergency diesel generators units, were installed in the basements of the turbine buildings. Positioned below grade and in close proximity to the seawater intake channels, these basements experienced rapid flooding when the tsunami surpassed the seawall, resulted in immediate loss of all AC power. Ground level electric switchgear rooms. Essential electrical switchgear and power distribution panels were situated at ground level. Without elevation or waterproofing measures, flooding these areas prevented the operation of the generators that remained functional. Units 5 and 6, these are the only generators that were protected. These are located in separate buildings at higher elevations. These units were not affected by the tsunami, ensuring that backup power remained available and prevented core meltdowns in units 5 and 6. Chains of events following power loss. Massive flooding hits the site, backup generators and turbine buildings' basements instantly submerged. Seawater also destroys seawater pumps and electrical switchgears. Complete station blackout. No AC power for cooling batteries provided only a few hours of limited control. Cooling stops across multiple units. Reactor water rapidly boils off, fuel rods become exposed, and temperature soars above 2000 degrees Celsius. Chemical reactions escalate. A zirconium cladding reacts with steam. Large volume of hydrogen gas pressure builds inside containment. Hydrogen explosions rip through buildings, units 1 and 3, and suffer massive structural damage. Debris and radiation make on-site work extremely difficult, and recovery becomes impossible. The roads destroyed, equipment flooded, cables unsuitable. External generators can't be connected to dead switchgear. Final outcome, cooling never restored, core meltdowns in units 1, 2, and 3. The regulatory nuclear reforms. After this, engineering for nuclear reactors needed a new reform. Structural reinforcements for the tsunami walls, the now mandatory 15-meter tall, and also flood-sealed electrical rooms, elevated armor backup generators. Also, there was a power and cooling redesign, triple redundant power sources, multiple emergency power fleets, independent cooling pathways, regulatory overhaul, new nuclear authority. The NRA was established with the hardest safety standards in Japan history. Hydrogen Now, the also severe accident defense, um, hydrogen venting towers, seismic reinforcement across systems, multi-layered backup systems were engineered once was just not enough.